Hi everyone, in this video we'll walk through building a Retrieval Augmented Generation pipeline using Moorcheh and LlamaIndex focused on healthcare. We'll show how to upload real scientific and clinical documents related to diseases like tuberculosis and pancreatic cancer, semantically index them, and run advanced queries over this data using LLMs. This demo uses the Moorcheh vector store, which is now available as an official integration within the LlamaIndex framework. You can find the full open source implementation there as seen on the screen. The README in the Moorcheh directory walks through the installation, setup, and example usage. It provides a step-by-step guide for initializing the vector store, uploading documents, and running queries. If you navigate further into the base.py file, you're able to access a better understanding of how core class and methods for integrating LlamaIndex within Moorcheh SDK works. So, whether you're a medical researcher, student, or AI enthusiast, this demo shows how vector search can transform complex medical information into insightful answers. Let's get started.
So all of our code is available on the Moorcheh example GitHub page. And if you navigate to the Analyzing Healthcare Documents with LlamaIndex, you'll find our Python file, our README, and our queries.csv file that we'll be using today. To show off our code, we've actually copied all of it into a Google Colab for better readability. So to start, please install all of these necessary packages. And we'll also be importing all of these packages as we'll be using them to make sure our RAG pipeline works. Next, we have the logging setup. And here we initialize sort of the Moorcheh client. So we've set our Moorcheh API key and OpenAI API key in our environment variables, as shown here. We've also used the OpenAPI key to initialize the LM object, and we've set it to an OpenAI model. This is an optional step that you can do if you want to use an LLM that's integrated with LlamaIndex instead of using the LLMs that have been integrated with Moorcheh SDK to get your answer. So this is completely optional, but you can do it if you want a specific LLM to use to answer your questions that's available on LlamaIndex itself. Next, we've set our namespace name, and we set the document's file path, and this is the file path to the folder that holds all of the documents that we'll be using. We also have the namespace type, which is text, but you can set it to vector if you would like to upload vectors rather than text documents. We also have the queries CSV path, and this is just this CSV file that holds all of our queries. And we have the output CSV path, which holds the file path to the answer CSV that will contain all of our answers to our queries. We also set top K to 5, and this means that we'll be returning the top 5 most relevant chunks from the documents to answer our questions. So let's take a closer look at some of these documents. First, we have the queries.csv file, and this is the file that holds all of our queries as shown here. And we also have our documents folder, and this holds one document. And essentially, this document is a document that holds information on tuberculosis and pancreatic cancer. And it comes from sources like NCBI, Archive, Mayo Clinic, and it's basically a very informationally dense document with a lot of information on two of these diseases, and we'll be using Moorcheh and LlamaIndex to kind of make sense of these documents and what the content and answer some of our questions. So next, we'll be chunking our document and we'll be loading it first, and we'll setting the chunk size to 1024 characters and the chunk overlap to 20 characters. Feel free to set this to your own specifications. And after that, we're going to create the Moorcheh vector store with our Moorcheh API key, namespace name, namespace type. We set the vector dimension to none because it is a text-based vector. For a vector type vector store, just set it to the dimension of the vectors you want to upload. And we also set add sparse vector to false. You can set it to true to make use of LlamaIndex's sparse embeddings. And then we just initialize storage context and index to upload the documents. And this is the output shown afterwards.
Now we can move on to our generate answers method. But before I explain this function in more detail, an important task becomes to understand our query strategies. So if you look at our query.csv file, we tested our pipeline with 3 tiers of queries. The first tier included simple factual questions like what is tuberculosis or what is the infection rate of tuberculosis. The second tier focused on casual and demographic reasoning, such as what are some of the main causes of tuberculosis and which demographics are the most affected. But lastly, the third tier involved high level research questions, such as what role does the tumor microenvironment play in pancreatic cancer treatment resistance? So, as you can see, these questions are pretty information heavy and they require the synthesis of information from multiple sections. So going back to our generate answers function, as you can see here, we allowed it to read the queries.csv file. And from that, we use the get generative answer method. In here, we use the AI model Claude 3.7 from the Moorcheh SDK, but there we also have a specific parameter called LLM. Right now it's set to none because, as I mentioned earlier, we're using the model from the Moorcheh SDK. However, if you want to use an LLM from the LlamaIndex SDK, you can feel free to set it as so. So if we run this function, we can get the following answers.csv files. And this answers.csv file reports the query and all the generative answers as seen on the screen right here. Our system performed well across the board. It was able to deliver accurate summaries of trial results, treatment comparisons, and staging logic. So, for example, if you look at question 8, when we asked about the TNM stage of a 2.3 centimeter tumor in the head of the pancreas, the system correctly identified the classification as T2N1MO, corresponding to stage 3 pancreatic cancer, and this required precise extraction of clinical details and correct interpretation of staging definitions, which the system handled with clarity and accuracy.
So to wrap up, this healthcare RAG pipeline showcases how semantic search powered by Moorcheh and LlamaIndex can deliver accurate, context-rich answers over complex clinical and scientific texts. So we'd like to thank you for taking the time out of your day to watch our demo, and we hope to see you using Moorcheh in the future. Thank you.